The Motorola one-point wireless suite, a complement to our hardware solutions, features powerful software tools that help customers design, deploy, manage, and secure trusted high-value Motorola wireless networks. The one-point wireless suite leverages Motorola's deep wireless expertise in helping customers design better networks, deploy them faster and more cost-effectively, and comprehensively manage them for maximum availability and security. This video series, composed of 4 segments, provides an overview on the capabilities of Broadband Planner, a software solution which helps network designers and system integrators create compelling quote responses through quick and easy network design workflows and rich Google Earth export features. Broadband Planner enables customers to design cost-optimized networks that can be trusted to deliver the required coverage. Integrated measurement tools help streamline deployment. Broadband Planner replaces Motorola's legacy Mesh Planner software solution and supports planning of both mesh and point-to-multipoint FSK and OFDM products. Now let's take a closer look at Broadband Planner. One of the first aspects of Broadband Planner is the ability to bring in the environmental information into the software. Here we're giving you a graphical example of the terrain in this area. You can see the bumpy mountains here in this area and the flat river running through the city, as well as the some trees and residential areas over here. I can hover my cursor at each point and get a terrain height. You can see it there as the second number in the tooltip. The terrain height at this point is 186 meters. Moving over here to the river, we've got 147 meters. That's obviously a really big difference and would make quite a difference in the RF propagation as to where we put a radio. So the terrain is kind of the foundation of the environmental information. Then we can come over and look at the different clutter properties, and those are represented by the different colors on the maps here. I'm looking at the properties of the clutter on this map, and you can see over on the left the categories are represented both by numbers and different colors. For each category, we get to define whether we ignore the category entirely, or if we will for open water here, treat it as an obstruction, something's going to impede our signal, either a building, a foliage, etc., anything with any height that is going to impede our signal. We define the obstruction type within the software as well as the height. And this dialog makes it very easy to do some what-if scenarios. If we were going to do an RFP and we didn't have high-resolution information, we can use low-resolution information and modify these heights on the fly to try kind of a best case and worst case scenarios as far as the heights go. So I can say I can run one prediction model with the height for the residential area only at 6 meters, and that's going to give me some pretty good propagation. Then we could pretend they're all 2-story houses maybe, and now the height goes up to 9 meters, and that's obviously going to make a big difference in the propagation, how the radios are going to be handled. In addition, when responding to an RFP, if we need to do something very quickly, we can get terrain and street maps pretty much anywhere in the world for free. What we can't usually get is clutter, though, the clutter that you see on top here, the different colors. So in lieu of having nothing and just working with terrain, which is rather an optimistic approach, we can create a clutter map from the terrain. So given the terrain, we can kind of drape a generic type of clutter at a certain height above the terrain, and that's going to give us a slightly more realistic approach as opposed to just using the terrain, the flat earth. And then we can always go in later if we want to and take the time to actually go and paint the clutter in a different way, maybe change some things, make some things higher. I could make this lake bigger. I could change this residential information, etc. So we give people the ability to work with very little data and free data to be able to create an accurate map and use it with the software. Along with the map information, the roads, the terrain, and the different clutter types here, we also need to talk about the potential mount points for the equipment. We can't just hang equipment wherever we would like. There's usually a finite area where we can actually get power and have an area high enough for our equipment. For that, we have something we call mounting points. Mounting points are potential locations where we can locate our equipment, and we have several different ways to bring those in. The simplest is to actually just add them manually. If you happen to know where a mount point is located, maybe it's a street light or a building or something, we can define the color type, the height of the mount point. I'm going to say this one is 8 meters. Say add mount point, and I can zoom in and say, hey, I know there's a mount point. I can put some stuff right here and maybe right here. And maybe through my predictions and research, maybe one of those will turn out to be better than the other. But they're both potential mount points. If we are doing something like responding to an RFP and we don't have any information about the area yet that we can use, we can also make some guesses as to where mount points would be. Instead of putting them manually, I can say, well, I know where the streets are, and I'm betting that there are street lights within along the streets. So I can say I would like to create mount points along the streets at 7 meters high. So we're defining not only the latitude and longitude of each mount point, but how high our equipment would be if we were to mount it there. And I'm going to use blue for the color for this one and place them every 120 meters along the streets. And what it's going to do is put a mount point at each corner as well as every 120 meters along the streets. And so if we have an idea of how the street lights are spaced out in the area, we can just input that there, and it gets us started and gives us an idea of where mount points might be when we don't know. So there we see it added 31,800 mount points in this area. This is about a 35 square mile map here, and so every blue dot you see now is a potential mount point where we can place equipment. So that's the automated version to create mount points automatically along streets. You saw the manual version. We also have one more. If you happen to have a spreadsheet, maybe you have something from the city that actually has the lat-long coordinates of a set of mount points, we can import that as well from a spreadsheet, and that's going to be the most realistic of everything here is a defined database of mount points for the area. Another useful map feature is the path profile tool. This lets us look at the terrain as well as the clutter between any 2 points on the map. So I'm going to select this as my start location and then drag it out here. You can see what's happening there is it's showing me the start and ending point and everything that's in between. So I started on a pretty tall hill, as you can see in the terrain right there, and I've kind of fall off the hill. There's a little valley here, and it goes on from there. And we've got the terrain, the lay of the land, as well as the obstructions on top of the terrain. You can see how those deeper shades of red, those clutter categories, we made a little higher in the last segment, the clutter property segment. And so that's reflected here. Once we define the 2 points, we can go along the path here, and it's going to tell us at each point how high above the terrain and clutter we are. So you can see here at this point I am 39 meters above the terrain, but only 24 meters higher than the clutter. So the clutter is pretty high at that point. And we can see, just how we're doing. Are we skirting over the obstacles? Are we going right through them, etc.? That's obviously going to make a big difference, especially with the line of sight equipment. And the path profile will let you see exactly what's happening between these 2 spots, and maybe it will give you a clue as to why you can't make a certain connection. You can see if something's in the way. In this example, if I have overestimated the heights of this clutter category, the darkest red here, that's the only thing that's standing in my way here between this connection having a full line of sight. So maybe I can go back and look at this particular area and see if I just didn't overestimate that. And if there aren't any very tall buildings there, I could take those away, repaint those, and then I'm going to get a full line of sight here.